In this video, I'll show you how to solve the ALEKS problem called writing the net equation for a sequence of reactions. This problem is going to give you two balanced chemical equations, and your job is to combine them and simplify them into one. Now what I've done is rewritten both of my equations down here. I've left the states off just to make it a little bit easier to look at. For your two equations, first thing that I want you to do is take a look at the products of equation number 1. That's these guys, and the reactants of equation number 2. And what you're going to do is notice that there is going to be one molecule in common between the products of equation 1 and the reactants of equation 2. And I want you to find that molecule. For me, it's the NH3. So I have NH3 listed as a product of equation number 1 and a reactant of equation number 2. I'm going to just highlight the NH3. This is where we're going to start. The first thing that you need to do is make sure that this molecule, my NH3 or whatever yours is, make sure that it has the same stoichiometric coefficient in both of the equations. So right now I have a stoichiometric coefficient of 2 for the NH3 in equation number 1, and I have a coefficient of 1 in equation number 2. My first job is to make sure that NH3 has the exact same stoichiometric coefficient in both equations. So to do that, what I'm going to do is multiply the whole entire equation number 2. I'm going to multiply the whole thing by 2. Multiplying everything by 2 means that I'm not changing whether or not the equation is balanced. It's still going to be balanced because I'm just doubling everything. But now I'm going to have the same stoichiometric coefficient for my NH3. And what you do here in this step, how you get the stoichiometric coefficients to be the same is going to vary based on your equation. I'm going to back up a little bit. I did see one that was kind of tricky. I'm going to modify mine just a little bit. So I saw one that looked kind of like this, where the stoichiometric coefficient was 2 for one of the equations and it was 3 for the other. And in a case like this, you would need to change the stoichiometric coefficients for both of the equations. So for the top one, I would need to multiply it by 3 so that this coefficient would become 6. And for the bottom one, I would multiply it by 2 so that this coefficient would also become 6. And then, of course, that means I need to change all the other coefficients as well. That one is pretty tricky. That's not what we have in this case. Let me get out of that. So I am just doubling the stoichiometry for my second equation, and then that's going to give me the same number of NH3 for both equations. So once you get the same stoichiometric coefficient on that molecule that you have in common between the two equations, then the next thing you're going to do is just add these two equations together, just like a math problem. So you're going to take all of your reactants and you're going to put all of them on the left-hand side of this new equation. So here I'm writing out all 4 of my reactants from both of the equations, and then I'm going to write out all of my products. And once you get it all written out, then you're going to go through and look for things that can be simplified or removed from the equation. So anything that you have on the left-hand side that is also present on the right-hand side in the exact form can be simplified or removed. I have N2 on the left-hand side, and I do have nitrogen on the right-hand side, but I don't have any N2 molecules, so I can't remove that. H2, I don't have any H2 molecules. I have H2O, but that's not the same as H2 all by itself. The NH3, I can simplify that. I've got 2 NH3s on the left, and I also have 2 NH3s on the right. And then I have O2 on the left, but I don't have any O2 on the right. So what I have left is my simplified equation. That's the answer to the question. Don't forget to put those states back in. I took the states out just to kind of save space and make it a little bit easier to write, but in your answer, those states need to come back. And I'm just copying the states from the original equation. And one last thing that you can do just to double check and make sure that you got the answer correct is that you can go through and make sure that the equation is still balanced, which it should be. This simplification process should not cause the equations to be unbalanced. So one thing that I could do is just go through and count. I've got 2 nitrogens on the left and I've got 2 on the right. I've got 6 hydrogen on the left and 1, 2, 3, 4, 5, 6 on the right. 8 oxygen on the left, 1, 2, 3, 4, 5, 6, 7, 8 on the right.